Hi, today we're going to go over how to graph quadratics with transformations. And transformations are certain types of properties that exist when we graph quadratics that makes it super easy for us to graph quadratics without having to plot points or do any annoying graphing. We can just look at the graph and we can say, I know the shape, I know what points I have to put, I know everything about it, just by looking at the equation for the graph. Now, we're going to start off simple, and that means using a simple equation to explore this. The simplest equation of all, what we'll be basing all these transformations off of, is y equals x squared. This is the simplest quadratic. It's got no other terms, just an x squared, and that's it, right? Why are we basing everything off this? Well, it turns out that when we add things to this equation, so to speak, right? If we have something like y equals 2x squared plus 2, each of these numbers are going to influence or change the shape of the graph by a certain amount that we can measure, we can know what it's going to affect. And so that's why we call them transformations. If we add certain things onto this equation to term x squared in other equations, we will know what changes will occur in the graph. So whenever we're graphing quadratics, we're always going to base our graphs off of the graph of y equals x squared, which is what we're going to be performing transformations on. So what is the graph of y equals x squared? Well, roughly, it looks like this. And let's say, to start out simple, I had something like y equals x squared plus 2. Now, to explain how this affects the graph, I'm going to start off by plotting a few points, just so we can get a general idea and figure out what's changed. So I'm going to do a table of values. I plug in 0, 0 squared plus 2, that's 2. Plug in 1, 1 squared is 1, plus 2 is 3. I plug in negative 1, I get 1. I get 3 again, because that negative 1 squares out to become positive. And so that we basically get the exact same graph, except moved up 2 units on the y-axis, right? We basically took x squared and we shifted it up 2. So that means that this number at the end here, this refers to how we're shifting up the graph, right? So if it was y equals x plus 4, we'd be shifting it up 4 units. However, say this is x squared minus 2. What is that going to do? So I plug in 0, I get negative 2. I plug in 1, I get 1 minus 3, 1 minus 2, or negative 1. I get negative 1, and I also get negative 1. So we see, once again, that, hey, if this is the same graph, just shifted down 2 units, right? So this final value, right, this constant basically refers to how you're shifting a graph up or down, right? So if it's negative, right, that means you're shifting it down on the y-axis. If it's positive, that means you're shifting it up on the y-axis. And that's the simplest transformation that we do for those values. Now let's get into something a little more complicated. And let's start off with what may at first seem to be an awfully complicated quadratic. This is a quadratic, and it looks super, super complicated. We're going to start off simple. Y equals x squared. And we're going to take slow steps to transform the graph of this into the graph of this. And along the way, we'll discover a couple of pretty significant relationships. So, let's begin. We, of course, start off by getting out our x squared graph. This is y equals x squared. And we're going to focus on the largest power term first, so the term with the largest degree, which happens to be, in this case, x squared, and in this case, x minus 3 squared. So I'm going to start by graphing x minus 3 squared and seeing what happens, right? what happens if this x is actually x minus 3? What does it do to the graph? As always, I'm going to take my table of values out, start plugging in values. I plug in 3. 3 times 3 minus 3 is 0. 0 squared is 0. So at 3, I'm at 0. At 4, 4 minus 3 is 1. At 5, 5 minus 3 is 2. 2 squared is 4. So, and of course, it's the same on the other side. So we start to see, basically, this graph is kind of the same as the graph of x squared. The only difference is we've shifted it over 3 units to the right. And so we say, okay, well, that's an observation. Anytime I have an x minus something in parentheses and I'm squaring it, right, I'm going to take my graph and I'm going to shift it over to the right that many number of units, right? So if it's x minus 3, I'm going to be shifting it over 3 units to the right. If it's x minus 10, I'm going to be shifting it over 10 units to the right. But just out of curiosity, what if this was, say, y equals x plus 3 squared? How would that change my graph? And I would probably say, we probably by now I have an idea of it. Just like when I added a negative sign and I did x squared minus 2, that shifted it down 2 units. When I have x plus 3 squared, I'm probably going to, since last time I shifted right, I'm probably going to shift left. But I want to make sure. So here's my x squared. And I plug in negative 3, and I get 0. I plug in negative 4, and I get 1. I plug in negative 5, and I get 4. So it looks like, of course at the same time, it looks like we have the same graph shifted over 3 units to the left. So when it's negative, right, when it's x minus 3 or x minus something squared, it means we're going to the right that many units. If it's x plus 3 or x plus something squared, it means we're going to the left that many units. So we have a start, right? We've got x minus 3 squared, but now what? So I'm gonna keep my original y equals x squared, but now I'm gonna add in that negative 1/2 x minus 3 squared. All right, so we already know our graph is shifted over 3 units to the right. But what is that negative 1/2 going to do to it? Let's find out. All right, so this is our, I guess I'll say starting point at y equals x minus 3 squared. But what's going to happen now? Well, the only thing I can say, though, is that negative sign, I know, right, is going to massively change the graph. Because every value of this, because we're squaring it, is going to be positive. But that negative sign means that I'm going to multiply all the positive values I'm going to get by a negative value. So my graph, instead of going up like this, is going to flip and go down like this. So anytime I see a negative sign on a graph of a quadratic like this, I know, okay, my function is going to be downward facing. It's going to be going down like this. So that gives me a start. But that still doesn't explain the 1/2. I want to plot points for this just to be sure. So let's say I'm at 3. I still get 0. If I plug in 4, I get 4 minus 3 is 1 times negative 1/2. That's just negative 1/2. It's the same as this. 5 minus 3 is 2. 2 squared is 4. Times negative 1/2 is negative 2. If I were to graph this out, I noticed an interesting phenomenon. This graph, it's kind of squished in comparison to this graph, right? And actually, we do have a word for that. We call this type of thing, right, where it gets squished out. and it becomes less and less steep in comparison to this one. We call it a vertical compression. And it occurs whenever this value out in front, this 1/2, this what have you, when this value is regardless of the negative sign, when this part is less than 1, right? So if it's a fraction, right? If it's something like 1/2 or 1/4 or 2/5, that means it's going to be a vertical compression, and it's going to be less steep than our original graph. So we know it's going to be wider. It's going to have a less steep slope. Okay, but what if it was greater than 1, right? What if instead of -1/2, we had -2? How would that change it? Now, this, of course, -2 is less than 1, but we're going to ignore the negative sign for now and say, well, what happens when, this isn't this part, this, single number part is greater than 1? So this we can explore that. So I'll get out and I'll start plugging in numbers to figure out. So let's do some value work. My x's and my y's come out. I'll have 3 is still going to be 0. 4 minus 3 is 1. Times -2 is -2. 5 minus 3 is 2. Times 2 squared is 4. Times -2 is -8. If we see something like this, where it seems to be getting a lot steeper, a lot quicker, especially in comparison to our original graph. So we say, hey, if the absolute value of the number out in front, which I'll call a, if this is greater than 1, it's going to get steeper, or what we call a vertical stretch. But if this whole number, the absolute value, is less than 1, and this in this like if this was -1/2, right? That the absolute value would be, that would be 1/2, which is less than 1. So it would be a vertical compression, and we'd have a decreased slope, a less steep slope, right? But we're not done yet. I mean, sure, we may have translated our graph to almost completion, but we still have that 2 we have yet to address. So I'm going to address it now. So currently we're at y equals -1/2 x minus 3 squared. How are we going to deal with that 2? As it turns out, it's actually not that bad. This is right. We went over before that if we had something like y equals x squared plus 2, we'd be just taking the graph of x squared and shifting it up 2 units. The same thing works for here. We're gonna, if we have, plus 2, we're gonna take this whole graph and we're gonna shift it up 2 units, which just looks like this. Just taking it, shifting it up 2 units. We're gonna bring every point, we're gonna add 2 units to its y value. And this here is our completed graph. We fully graphed it. And the great thing about this method of using transformations is that it's incredibly consistent, right? You start with your x squared, you do the necessary transformations to move each graph along, and you end up with what is absolutely guaranteed to be the proper graph. You won't have to do anything like plotting points, because once you know the rules, like, oh, if I add 2, if it's plus 2, I'm going to shift it up, or oh, if it's -1/2, that means A, it's going down, and B, it's going to be have a less steep slope, then it's far, far easier for you to graph than having to manually plot out points and say, is this the pattern? Is this the graph? Is this working? It's just a lot quicker and it's a lot swifter. So, to recap the rules, this value right here, this constant value hanging out, that's referring to its y position, right? So it's positive, that means you're taking your original graph, your x squared, you're going to be shifting it up. If it's negative, that means you're shifting it down, right? This x minus 3 squared, right? Anytime you see this, it means you're shifting the graph horizontally, right? So if it's x minus something, that means you're going to the right by that amount of units. If it's x plus something, that means you're going to the left that amount of units. Negatives, if you have a negative next to your x squared or x minus 3 squared or whatever squared term, that means you're going to flip your quadratic upside down so it curves downwards like this. And finally, if the absolute value of this whole thing is less than 1, it's going to be less steep. If the absolute value is greater than 1, it's going to be more steep. It's going to be sharper. And those are all the transformations. Just take your function, start it with y equals x squared, and progressively add parts of your function into there, and you will guaranteed get the graph of your function, of your quadratic. That is how you graph quadratics with transformations. I hope you enjoyed, and I hope you have a great day.